Hey Wildcats, today we're at journal page 53, solving mixed to practice all functions, quadratic, square roots, cube, and cube roots. All right, solve each equation algebraically and graphically. So example 1, let's start by solving algebraically, okay? So the first thing we want to do is subtract 2x and subtract 1 from both sides, okay? So then you have 2x squared minus 2x, 1 and 1 cancel, so 0 equals, cancels equals 0. Okay, so now we're going to factor out 2x from each of these terms. So that's 2x times x minus 1 equal to 0. Okay, so now we're going to set 2x equal to 0 and x minus 1 equal to 0. Well, divide this by 2, so x equals 0. Add 1 to both sides, x equals 1. Okay, so now let's check each of those values and maybe adjust the lighting there a little bit. So let's check x equals 0. So then that's 2 times 0 squared plus 1 equals 2 times 0 plus 1. So that's 0 plus 1 and 0 plus 1. So 1 equals 1, so that checks. Okay, now let's check x equals 1. So then that's 2 times 1 squared plus 1 equals 2 times 1 plus 1. 2 plus 1 is 3 equals 3, so that checks. Okay, now let's solve example 1 graphically. Now I'm going to graph the left side in orange and the right side in blue. Okay. All right. So to graph the left side, we start, our vertex goes up 1. Okay, so there's a new vertex, and we graph by direction. So we know that -2, 4, -1, 1, HK, that's a new vertex, 1, 1, 2, 4. But we see from here we have to multiply the y direction by 2. So 4 times 2 is 8. 1 times 2 is 2. 1 times 2 is 2. 4 times 2 is 8. Okay. Now remember, these are not points or directions. So from this vertex, we're going to go left 2, up 1, 2, 3, 4, 5, 6, 7, 8. Let me double check that. 1, 2, 3, 4, 5, 6, 7, 8. And then left 1, up 2. Right 1, up 2. And then right 2, up 8. Okay. All right, now let's graph the right side. Now here, this is linear, so we're just going to start our y-intercept at 0, 1. And we go up 2 to the right 1. So up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And now it's important to note that 2 divided by 1 is equivalent to -2 divided by -1. So we can actually go down 2 to the left 1, 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 down 2 to the left 1. Okay. Now we can see here that it intersects at 0, 1. Now, when you're talking about solutions, it's the x value of the point intersection, so x equals 0. Okay, and then here it intersects at 1, 2. And again, the solution is the x value, so x equals 1, which you can see here that the solution algebraically is the same as solution graphically. Okay, so go ahead and finish up example 1. All right, now let's take a look at example 2. All right, now solve algebraically. When there's a trinomial, we think about factoring, okay? So we know 2 parentheses equals 0. All right, so I had to grab a note card because we want to solve this by reverse box method. Okay, first term, last term. Now we know that 2x and 1x make 2x squared, okay? And we know that these two need to combine to be negative 5x. Okay? Now, we need to find all the combinations that make 3 combine to be negative 5. So we know that negative 1 times negative 3 is positive 3. We know that negative 3 times negative 1 is positive 3. Now, this one you have to remember that you're multiplying the first term times 2 and the second term times 1, okay, to get negative 5. So okay, so 2 times negative 1 plus 1 times negative 3 equals negative 2 minus 3 is negative 5. Okay, so that works. So the negative 1 goes with the 2, so negative 1 goes here. And then negative 3 goes with the 1, so negative 3 goes here. Okay, so then let's check. 1x times negative 3 is negative 3x. Negative 1 times 2 is negative 2x. Negative 2x and negative 3x combine to be negative 5x. So this checks. So we have 2x minus 3 and x minus 1. Okay, so now we set 2x minus 3 equal to 0 and x minus 1 equal to 0. All right, so we're going to add 3 to both sides, so you get 2x equals 3. Divide both sides by 2, so x equals 3 divided by 2. Which as a decimal, that's x equals 1.5. Okay, now here we're going to add 1 to both sides, so x equals 1. So now let's check each of our numbers. Okay, so let's check x equals 1.5. Okay, so then to check, we plug that in, so that's 2 times 1.5 squared minus 5, excuse me, times 1.5 plus 3 equals 0. Okay, now I would recommend using the calculator to calculate that because, so let's go here. So we're going to go to new document, no, add calculator. I think, let me adjust the lighting a little bit. That's probably good. Okay, so now we're going to put 2 parentheses 1.5 squared minus 5 times 1.5 plus 3, which equals 0. So this checks. Okay, so 0 equals 0, so this checks. Okay, so now let's check x equals 1. So then that's 2 times 1 squared minus 5 times 1 plus 3 equals 0. So then that's 2 minus 5 plus 3 equals 0. Well, negative 3 plus 3 is 0, so 0 equals 0, so this checks. Okay? All right, now to graph this, there's no real easy way to graph it without a calculator, so we're going to practice graphing this and finding these zeros with a calculator. Okay? So I'm going to go to On, New Document, No, Add Graph, and let me make sure I have the equation correctly. So then I'm going to type in 2x squared minus 5x plus 3 equals 0. Oh, wait, I'm sorry. Be careful, I'm glad I made a mistake. So if that happens, you go and go back, you don't put the equals 0. And ta-da, there's your equation. Okay? Now to find points, let's press Control T. Okay? Now, to graph this, okay, we want to go to an x is negative 10. So we want every point from negative 10 to 10 that we can graph. Now you can see here, we can't graph that point. It's too big, too big, too big. Still too big for the graph. We can graph from negative 1, 10. So negative 1, 10, there's our first point. Okay. 0, 3, 1, 0, 2, 1, 3, 1, 2, 3, 4, 5, 6. 415 is too big. Okay. Now we're going to graph the left side in orange. Okay. And we're going to graph the right side in blue. Now, you can see here that it definitely crosses it when x is 1, 0, but it's really hard to see when x is 1.5 to see where it intersects, okay? So this is, again, where you can use a calculator to find the intersection point. So we're going to press Control T to get rid of the table. Tab, we're going to graph 0, okay? Now, I'm going to come over here, click on it. I'm going to actually press Escape, sorry. See the hand? I'm going to Control click, grabs it, move this out of the way. Okay, press Escape. And then I'm going to move my cursor over here. See the hand? Control click, grab it. I'm going to move this out of the way. Press Escape. And then we're going to go to Menu, Analyze Graph. And then we want to find the 0. The zeros are the solutions. So it says Graph. So I'm going to click on this graph. Okay. Now I'm going to move the cursor to the left. Click and drag. Click again. There's one of them. So we know one of our solutions is 1, 0, and that's your x value equals to 1. But we know there's 2 zeros, so we're going to do this again. So Menu, Analyze Graph. We want 0 again. Now it says Graph, so we want this graph. Click. Now I'm going to come from the right side. So move to here. Click, drag, and then it tells you when the 0. Control click. Move that out of the way. Control click. So it's wanting this. So let's try another thing. Let's go to Menu, Analyze Graph. 0. And this is where you can see that graphing sometimes is more difficult finding the solution than algebraically. But algebraically, we know that one of the answers is 1.5. So we're going to try something a little different. Okay. So now I'm going to click on this red line instead of the blue graph. Click there. Now find the 0. Click and drag. So you can see here, it's not really working to find the 0. Okay. So we know though that the other 0 is 1.5, comma 0. So x equals 1.5. Now, and the reason why I put example 2, and I did this for this reason, the reason why I'm showing you the algebraic way and the graphical way is because sometimes the graphical way doesn't really work. If you were to rely on the graphical way for this problem, you would have missed x equals 1.5. Whereas since you used the algebraic way, you found both of the zeros, okay? All right, so now let's move on to example 3. All right, so now we need to square both sides. Okay, so then you're left with x minus 1 equals 1 minus x. Now to solve, what we're going to do is we're going to add x to both sides, and we're going to add 1 to both sides. So x plus x is 2x, negative 1 and 1 is 0, 1 and 1 is 2, negative x and x is 0, so you're left with 2x equals x. Divide both sides by 2, x equals 1. Okay, so now we need to check x equals 1. So we're going to substitute 1 in for x. So that's 1 minus 1 equals the square root of 1 minus 1. So you're left with the square root of 0 equals the square root of 0. So 0 equals 0, and this checks. Okay. All right, so now we're going to graph the left side and the right side. Now, I'm going to erase my work here so I don't accidentally graph with that squared, okay? Now, for the square root, we need to move the vertex, and that tells us we move to the right one. So, move to the right one, okay? All right, now we know the directions for square root are h and k. We know 1, 1, 4, 2, and 9, 3. Okay, so from this point, you go to the right one, up 1, to the right 1, 2, 3, 4, up 2, to the right 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. Okay. All right, now let's graph the right side. Now, the plus 1, and you might rewrite this so it's easier to understand, as negative x plus 1. It's easier to see the transformation. Okay, the plus 1 moves the vertex to the left 1. Okay, but this is where it gets tricky when there's a negative inside. That reflects back over the y-axis, so you're back to 1, 0. Okay, and then you graph by direction. We know that hk, 1, 1, 4, 2, 9, 3. But we have to multiply the x direction by negative 1. So negative 1 times negative 1 is negative 1. Negative 1 times 4 is negative 4. And then negative 1 times 9 is negative 9. Okay? So from here we go left 1, up 1. Left 1, 2, 3, 4, up 2. And then left 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. And let me, I don't know if you could read this clearly. Let me try writing it again. Negative 1, negative 4, and negative 9. Okay? Okay? You can see here that they intersect at 1, 0. Okay? So the solution would be the x value, x equals 1. Okay. All right, now let's take a look at example 4. Okay. Now to solve algebraically, we need to subtract 6 from both sides, so that's the cube root of x minus 1 equals 1. You're going to cube both sides. Cube uncubed root the cube root, so that's x minus 1 equals 1 cubed is 1. Add 1 to both sides, x equals 2. So now let's check, x equals 2. Okay, so then that's the cube root of 2 minus 1 plus 6 equals 7. Okay, so then you're left with the cube root of 1 plus 6 equals 7. Well, 1 plus 6 is 7, so 7 equals 7, so this checks. Okay, now let's solve it graphically. Okay, so we're going to graph the left side in orange and the right side in blue. Okay, so first we move the vertex to the right one up 6. So to the right one up 1, 2, 3, 4, 5, 6. Okay, and then we know the directions for cube root are -8, -2, -1, -1, HK, that's the new vertex, 1, 1, and 8, 2. Okay, so from the vertex, remember these aren't points, these are directions. So from here we're going to go left 8, 1, 2, 3, 4, 5, 6, 7, 8, down 2, left 1, down 1, right 1, up 1, and then right 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2. All right, so now we graph the horizontal line at 7. So 1, 2, 3, 4, 5, 6, 7. Okay, so you can see here that they intersect at when x is 2. So 2, so the point is 2 comma 1, 2, 3, 4, 5, 6, 7. So 2 comma 7. But the solution is the x value, so x equals 2. All right. So if you would finish example 4. Now, this probably hasn't been bothering you, but I've been thinking about it this while I've been making this whole video. Is example 2 graph. I really feel like I could have shown you a better way to find where they intersect, okay? So this is a special case in that they intersect at 0, right? So what you can do, okay, is to find out, right, what we're going to do is I'm going to go to on, new document, no, on, new document, add graph, and I'm going to type something in to show you something cool here. 2x squared minus 5x plus 3. Okay, control T. Okay, now 1, 0 pops up there. Okay, but if we do this, if we go to menu, table, edit table settings, and we want to start at 0, but instead of 1 by 1, let's go by 0.5. Press enter. Now you can see that 1, 0 and 1.5 0. Okay, so you can see here that in fact 1, 0, x equals 1, and 1.5 comma 0, where x equals 1.5 are your solutions. Okay, but I'm hoping you see that sometimes graphing is more difficult than solving algebraically. Okay, so that's why you want to be able to do both methods, both algebraically and graphically. Okay, so with that, go ahead and finish up your examples and start working on your assignment, and have a wonderful Wildcat day.